Let's now look at multiplying and dividing rational expressions. We will be factoring in this section, but let's look at how we multiply rational expressions. If capital P over capital Q and capital R over capital S are rational expressions, then to multiply them, you multiply the numerators and you multiply the denominators, and then you simplify the fractions as necessary. So it's just as if you're multiplying fractions. It's just that when we come across those that have polynomials in it, we're going to have to factor them first. Okay, so look at these two multiplication problems we have here. Look at 6x squared over 10x to the third times 5x over 12. Well, we're going to cancel. We're going to use our concepts of canceling any numerator with any denominator, and that will allow us to simplify this as we multiply. So actually, before we multiply, we can look to see what any numerators have in common with any of the denominators. For instance, the 6 and the 12, if you want, you can reduce those. You could actually reduce the 6 with the 10, but we can also reduce the 6 with the 12, meaning what's the biggest number that divides evenly into 6 and 12? That would be 6. 6 divides into 6 one time, and 6 divides into 12 two times. So they become a 1 and a 2. Okay? Then the 5 and the 10 can reduce. 5 divides into 5 once, and 5 divides into 10 twice. So I'm going to rewrite what we have so far. We have a 1x squared, which is just x squared, over 2x to the third. Times now 1x, or just x, over 2. All right, now that can be simplified some more, because honestly, the numerator, the x squared times the x in the numerator, really becomes an x to the third, and that x squared and that x actually cancel with the x to the third down here in the bottom. Okay, so when we cancel that, those become 1s in the numerators now. That becomes a 1. And what we're left with is 1 over 4. Okay, so we did a whole lot of canceling, and you have to remember your rules for exponents, how they reduce and everything. Okay, so with the next problem, we have negative 8x squared over 5y times 3y squared over 16x squared. Well, I see right now that I have an x squared and an x squared that cancel. Those go away. They become 1s. Okay? That's kind of awkward if I write it like that. But they become 1s. Okay? What else? The 8 and the 16 reduce. 8 goes into 8 once, and 8 goes into 16 two times. Then we have the y down here cancels with one of the y's up here. So let's simplify it a little bit. Let's write it out so we can see what we have. There's a lot going on here. So we have a negative 1 over there because the 8 was canceled and the x squared was canceled. So it's a negative 1 times 3y, which is negative 3y in the numerator. And what do we have left in the denominator? The x squared's canceled out. The 16 became a 2. And we have a 5 there. So 5. So that's a 10. I think that's it. Over 10. So it simplifies. It can't be reduced any further to negative 3y over 10. Okay? Let's look at a couple more. With 4a over 5 times 3 over b squared, there are no numerators or denominators, numerators and denominators that can cancel here. Okay, so all you're able to do is just multiply the numerator, so that gives you a 12a, and multiply the denominators gives you a 5b squared. Okay, now with the next one, we have some q's that can cancel. Two of these q's cancel with two of these up here. And it leaves you just what? A q up there at the top on the right. And let's see, the p to the fourth cancels with the p to the fourth. Those become ones. Then we have the 3 and the 9 reduce. 3 goes into 3 one time, and 3 goes into 9 three times. So let's see what we have. We have negative 3p. Those cancel, so all we left is 1 times 2q. So negative 2q all over. Let's see, the q squares cancel, and a 3 is the only thing that's left. So we have negative 2q over 3. So a general description of how to multiply rational expressions is this. Completely factor the numerators and the denominators. Then multiply the numerators and denominators. Simplify or write the product in lowest terms by dividing out the common factors. So here's an example. Let's go ahead. We have x squared minus x over 5x times 15 over x squared minus 1. Well, with the first fraction here, we need to factor out an x. Remember, we're factoring everything first, and then we're going to see what can cancel. Factor out an x, and we have an x minus 1 here, all over 5x, times 15 over what? X squared minus 1 is the difference of two squares. That's an x plus 1 times x minus 1. Okay, so now you can see that the factor x minus 1, change colors here, x minus 1 cancels with this x minus 1. Okay, the whole factor cancels and they become ones. Then the x here cancels with this x up here. So those are ones, so they're multiplied now by 1. Then the 5 divides into the 15 3 times. And the 5 becomes a 1. So what we're left with is a 1 times 3 in a numerator, which is 3, all over 1 times x plus 1 times another 1 in the denominator. So all we have is x plus 1. Okay, here's another where we're going to factor all of our numerators and denominators, and then basically multiply by canceling, and then we'll keep whatever numerators and denominators are left. Okay, so let's factor. With the first fraction, rational expression, we can factor out a 3. So we're left with x plus 1 all over. Here we can factor out a 5x. And then we're left with what? 1 minus x times, now let's factor this other one. Now, if you go off to the side now and factor this one by grouping, I'm not going to do this one because the factoring we've handled already in chapter 6, but if you factor this using the AC method, we're going to find two numbers that multiply to -6. I'm sorry, multiply to -6, but add to 1. So you have to figure out that factoring on your own, but when it's factored, we get 2x plus 3, that's a 3, times x minus 1, all over. Now 4x squared minus 9 is a difference of 2 squares. So that gives us 2x plus 3. Why is these 3? Oh, these 3's acting. 2x plus 3 times 2x minus 3. Okay, so if you look for the things that are common, what do we have? Okay, I'm going to change my color here. We have 2x plus 3 here and a 2x plus 3. Those go away. Okay? So then, after we have that canceled, let's look carefully at what we have. We have 3 now times x plus 1 times x minus 1 all over 5x times 1 minus x times 2x minus 3. That's what we have left. But look at x minus 1 at the top, and then 1 minus x at the bottom in the denominator. They're exact opposites of each other. So remember, I can rewrite them. When you have the exact opposites, they cancel but become a -1. The factor that factors out of those two is a -1. And you can put that -1 anywhere you want to. They don't just cancel, but they cancel to a -1 because they are opposites of each other. So now let's see what we have. We have 3 times x plus 1 and we have that negative sign at the bottom, or we can put it at the top. I'm going to go ahead and put it at the top, that negative sign that was at the bottom. And then we have 5x times 2x minus 3. Now look at it and tell me if anything, well, you can't really tell me, but you can think about, is there anything else that can be canceled? So we have -3 times x plus 1 in the numerator and 5x times 2x minus 3 in the denominator, and that is the simplified version of this multiplication. Okay, we've multiplied and canceled, simplified everything. Okay, let's try another one. Okay, we're going to start out by factoring. Okay, factor everything. Factor, factor, factor. Okay, so in the first numerator we can factor out a 3. And we're left with 2 minus, x. Over. Here we can factor out a 6x. 6x times 1 plus x times. Now, when you factor 3x squared minus 2x minus 5, if you go off to the side and factor it, which I did before I started recording this, I have 3x minus 5 times x plus 1. All over x plus 2 times x minus 2. Alright, so let's see what we can cancel. Well, we have an x plus 1 at the top and a 1 plus x in the denominator. Those cancel. Then we have a, let's see, a 2 minus x and an x minus 2. Well, those two cancel into a negative 1. So I'm going to put my negative sign out front, in front of that 3. Okay, so let's see what we have if we can make this neater. What do we have left? We have 3. I'm sorry, negative 3 times 3x minus 5 all over 6x times x plus 2. Okay, but look at the 3, the negative 3 at the top and the 6 in the bottom. That reduces, so we have that 3 divides into that 6 2 times, and this becomes a 1. All right, so ultimately what we have is negative, what? Negative, or the opposite of, I'm going to put the negative out front, 3x minus 5. Sorry about that, my phone was ringing. Okay, and then we have 3x minus 5 in the numerator, and we have a 2 and an x, and then an x plus 2 in the denominator. And then remember that negative sign, I brought it out front because that came from canceling the 2 minus x and the x minus 2. Okay, moving right along. Now to divide rational expressions, remember, they're nothing but fractions. So you divide them the same way you divide fractions. But how do you divide fractions? You always change fraction division to multiplication, and you change the second fraction to its reciprocal. So we're going to still factor everything, but we're going to change the operation to multiplication, and we're going to change the second fraction to its reciprocal. So to divide, that's all we're going to do. So let's look at this one problem. 7x squared over 6 divided by x over 2y. So that's going to become 7x squared over 6 times 2y over x. Now remember, what happens when you multiply, everything basically joins together. So if you want to write it all together so you can see exactly what's canceling, it's fine. But you know, it would save you a step if you don't do that. So I'm going to go ahead on and multiply everything just so you can see what I'm talking about. Look at 7 times 2 is 14, and x squared y is in the numerator. Then we have 6x in the denominator. So now you can see that, well, what cancels? Well, a 2 will divide into 14 7 times. 2 will divide into 6 3 times. This x in the denominator cancels with one of the x's at the top. Okay? So, and then the y remains where it is. So we have 7xy in the numerator all over 3 in the denominator. So it just changed to multiplication, and you do the exact same thing you did before when multiplying. Here's another one. Okay, 5a cubed b squared over 24 divided by 10a to the 5th over 6. It becomes a cubed b squared over 24 times 6 over 10a to the 5th. All right, so let's see. We now have, if you want to multiply it, you can, but you can go ahead on and simplify by canceling, for instance, the 5 with the 10. This 5 becomes a 1, and this 10 becomes a 2. Then the 6 divides into 24 4 times, and this becomes a 1. Then I say let's write it again so we don't lose track of what we're doing. So what do we have in the numerator now? We have a cubed. Man, these 3's with this pen, they're about to make me fuss. A to the 3rd b squared, that's it for the numerator, over 4 times 2 is 8, a to the 5th. Now, we want to cancel whatever we can cancel. The a to the 3rd in the numerator cancels with 2 of those factors of a in the denominator. So that goes away in the top. So we're going to be left with b squared in the top and 8a to the what in the bottom? 8a squared, right? Because if there's 3a factors in the top and 5 in the bottom, then 3 of the ones in the bottom will cancel with the 3 at the top, factors of a, and it will leave you 2 factors of a in the denominator right here. Okay, now starting here, we need to make sure we factor everything. Well, the first numerator here, x minus 4 quantity squared, it's already factored. We just have to factor this other stuff, the 3x minus 12. However, we need to rewrite it, and I'm going to rewrite it and factor as I go, because I don't want to be writing extra stuff. X minus 4 squared over 6 times 2 over 3 times x minus 4. Now, notice what we have. We have 2 factors of x minus 4 in that numerator. Okay? That cancels with the one factor of x minus 4 in the bottom, in the denominator. So we are left with an x minus 4 in a numerator. Then look at the 2 and the 6. They cancel. 2 goes into 2 once, and 2 goes into 6 3 times. Okay? So what we have after canceling or dividing out those factors, we're left with an x minus 4 times 1 in the numerator and a 3 times 3 in the denominator, which is 9. Okay? 9. Cool. Here we go again. So we need to factor now. We're going to factor out a 2, and that gives us a 5x minus 2. Then we're going to factor that difference of 2 squares. X squared minus 4 becomes x plus 2 times x minus 2 times, now I'm going to flip the reciprocal now, change the second fraction to its reciprocal. We have x plus 2 over, let's see, we can factor out an x squared, and it would leave us a 5x plus 2. Oh, okay, and that numerator over there, I'm looking at this 5x plus 2. It should be a 5x plus 2 over here in the numerator as well. Look where I factored that first 10x plus 4. That should be plus. Okay, I was looking for some things that were going to cancel, and I noticed that I'd made a mistake. So you have to pay attention when you're doing it as well, because remember, you're trying to find some things that cancel. All right, so let's see, what do we have? We have 5x plus 2. That cancels with this 5x plus 2. Then we have an x plus 2. Now this becomes a 1 now. You got to remember those 1s cancels with the x plus 2 down here. So ultimately what we have is 2 times 1 in the numerator over x squared times x minus 2. Let's factor 3x squared minus 10x plus 8. Okay, this factors, when you go off to the side, you will find that it factors to 3x minus 4 times x minus 2 all over, let's see, we can factor out a 7 and we get x minus 2. Now we're going to multiply. Because this is a division problem, we're going to change it to multiplication. 21 moves to the numerator. And the 9x minus 12, we can factor out a 3. And then we have 3x minus 4. Okay, so we have a 3x minus 4 that cancels. Those become 1s. The x minus 2 cancels. Those become 1s. And the 7 cancels with the 21 3 times. And then look, be careful. The 3 up here cancels with that 3 down there. So those go away and become 1s. So we have a whole bunch of 1s. 1 times 1 in the numerator times another 1. We got all of those 1s, and this whole thing simplifies to 1. It's pretty cool. All right, now here we got some mixed problems. We're going to multiply the first one. So we have x plus 3. It cancels with an x plus 3 because it's multiplication. You can do that. So you have a product of 7 over x. This next one's a division problem. Do not be tempted to cancel that x plus 3 because it's division. You cannot cancel across division. So this becomes x plus 3 over x times x plus 3 over 7. Okay, and then in order to multiply, you really don't have to go ahead and multiply this thing out. The numerator times the other numerator, the binomial x plus 3 times x plus 3, you don't have to go ahead on and multiply that out. Leave it in the factored form. Write it as x plus 3 squared. Okay, all over 7x. And then that way you can see it's in the factored form. You don't multiply it out to FOIL it. Here, this is the last example. So let's see. We have to factor. So we have 3 minus x in the numerator. And then the denominator, we're going to have 2 numbers that multiply to 5, positive 5, and add to 6, 5 and 1, times, now this is multiplication. So we have 2 that factors out over here, and that leaves us an x plus 5. Then we have an x and an x, and I need 2 numbers that multiply to positive 12 but add to negative 7. That's a negative 3 and a negative 4. So we have an x plus 5 that cancels with an x plus 5. We have a 3 minus x and an x minus 3. Remember, they're exact opposites of each other, so they become a negative 1. And then that's all that we have that can cancel. So we have a negative now, and then a 2 in the numerator. So remember, all of these are 1s, everything that cancels. So a negative, then we have a 2 in the numerator, and x plus 1 in the denominator times x minus 4. Okay, so you have enough to work the problems in 7.2. This section is really easy. If you learned how to factor, you can go ahead on and do these homework problems. Check you on the next section.